What we need to learn how to do is draw an angle in standard position. So I have a couple examples of some things I hope that kind of make sense to you. Let's look at our first one right here, where I have an angle that's described all the way around a full revolution of the circle. And a full revolution is the same thing as 2 pi radians. If I have an angle that's described 3/4 of a revolution, well, that's 3/4 of a full 2 pi, because 2 pi is a full distance all the way around. So if I have 3/4 of a revolution, you notice that my angle describes comes all the way down and starts to point south on the y-axis. 3/4 of 2 pi, this angle becomes 3 pi halves radians, or 3 halves pi radians. What about an angle that's a straight angle? Well, that's 1/2 of a revolution. 1/2 of 2 pi, which is a full revolution. 1/2 of 2 pi equals pi radians. And then lastly, I have one that's at that classic 90-degree angle mark, where this is 1/4 of a revolution of a full 2 pi, and that results in, if I multiply those through, I get pi half radians. So I hope we kind of put this in the back of our mind a little bit as we think through how do we describe other angles and draw them appropriately. So let's look at an example where I have theta equals pi fourths. How would I draw that? Well, first of all, we want to get in a sense of is what's the revolution of pi fourths? How far around the entire circle is that? Well, we know pi fourths is 1/8 of a full revolution. And you can do the math backwards and look at that. 1/8 times 2 pi reduces down to pi fourths. So knowing then that pi fourths is 1/8 of a full revolution, we can draw our circle, draw our standard initial ray along the x-axis, and then divide this up into sections of 8. I know up here at the vertical mark, that's 1/4 of the way around. So 1/8 is going to be right there in half through the first quadrant. And so the angle that we created, this angle of theta right there, is pi fourths radians. Wanted to look at two different ways to figure out how do we draw this particular angle into standard form. First of all, as it might be a good time to remind you that notice I wrote pi equals 5/4, theta equals 5/4 pi. I didn't say radians, but can you understand that this world is radian world as opposed to the degree world? We're going to drop radians, and if we put it there, it's for emphasis, not because we need to. So this should be understood that this is a measurement in radians to begin with. All right, how do we draw this? Two different ways we can think about it. First way is we can recognize that 5/4 pi is 5/8 around a circle. So 5/8 of 2 pi. Had to do some little mental mathematic gymnastics backwards, because if I work this backwards, 5 times 2 divided by 8 reduces to 5/4. So I see that it is 5/8 around a full revolution. Another way I can think about it too, another method maybe that you can find helpful or might be helpful, is recognize that 5/4 pi equals pi plus pi fourths. And maybe we can look at both of those measures and add them together. So let's draw our circle. Draw our XY coordinate axis on top of that. And then where is 5/8 around the circle? Well, the circle is already divided into fourths, so we divide it into eighths. We just divide each of those quarters into another spot. And so now I can see it's divided up into eighths. And 5/8 of the circle in the positive direction. This is a positive 5/4, so I start from here and work my way down to that mark right there. So that angle right there is my angle 5/4 pi, which is measured in radians. I could also look at this other method where it said, first of all, I have a measurement of pi. Pi, if you remembered, was 1 full or 1/2 rotation. From this line all the way to this line. That's pi. And then with that, I add another quarter pi to that, which is this last little mark right there, which is a quarter pi. So notice that both methods are great methods to be aware of, but I want you maybe also to be aware of the second method, because sometimes it's easier to break the problem up into smaller chunks, then solve it, than maybe solve the bigger chunk to begin with. Anyway, with practice, you'll determine which one you like the most. Let's look at another example. Oh, I have a negative measurement now, negative 3/4 pi. How do we make sense of that? Well, what I like to do is let's look at this absolute value portion of that. So let's look at what negative 3/4 pi, but the absolute value of that, which is 3/4 pi, and I use that to find the angle. Now, negative means I'm going to rotate the angle clockwise around the circle as opposed to counterclockwise. So I still have the same distance I'm going to look at. I'm just going to go in the opposite direction. And that tells me that's why I can evaluate it or look at 3/4 pi rather than negative 3/4 pi. So how do we convert that? Well, we have two methods. One method is 3/4 pi is the same thing as 3/8 of the way around a circle. 3 times 2 makes a 6. 6 over 8 reduces down to 3/4. So I can confirm that 3/8 is the distance around a circle to determine where my terminal ray will be at. The second method that we can use is we can look at 3/4 and break that on up into two different types of components. And so I can look at it as 3/4 pi equals is it 1/4 and 2/4? Yeah. So 2/4 pi plus 1/4 pi equals 3/4 pi. 2/4 is just 1/2 pi plus another quarter pi. So I can also break it up into two smaller components. What that allows me to do is I can draw my circle, draw my XY coordinate within that circle, and then from there, both methods will get us there. Start with my initial ray along the x-axis, sits on the vertex right there. I'm going 3/8 of the way around the circle, but in the negative direction. That's 1, 2, and 3. So my angle right there is negative 3/4 pi radians. Also too, if I looked at it this way, notice that first of all, I can subscribe and go around 1/2 pi, which gets me to the y-axis, and then beyond that, add another quarter pi onto it. And so both methods help me determine where the terminal ray is so I can draw the complete and correct angle. Again, this one was negative. Because it was negative, it was the same degree measurement, or the same measurement radians, but it went in the opposite direction. It went in the negative direction, so that's why I have to assign and be aware of the direction I was going as determined by that negative sign. All right, I think we got one more example to look at. 9/4 pi. How do we describe and draw that particular angle? Again, we have two different methods. One we can recognize is how much of a percentage around 2 pi's is 9/4 pi. So 9/4 pi is the same thing as 9/8 around the circle. 9/8 around the circle. Work our math backwards, make sure I got the right ratio. 9 times 2 is 18. 18 divided by 8 is 18/8, or reduces down to 9/4 pi. So I know it's around the circle 9/8. The other method we had is we can look at that and broke up 9/4 into both 8/4 pi plus 1/4 pi. 8/4 pi is 2 pi. It reduces down to 2 pi, and then plus the 1/4 pi. Again, this might look really hard to begin with as you're looking at this, and it looks like, well, Willie, you're going through it pretty easy. Well, we'll come with practice as we get used to knowing how far around circles we're going, and we're able to come up with these types of ideas, and we'll learn how to break them on up because we're not comfortable using radians as a measurement. It will take practice, and with practice, it will start to become a little bit more second nature. How do we draw that? Draw our coordinate plane with our circle in that. Have my initial angle. So notice then, and I'm going to break it up into eighths because it's in a factor of 8. And I'm going around 9/8 time. 1, 2, 3, 4, 5, 6, 7, 8, 9. So notice what I did. I went around a full rotation and then a little bit more. Or if you notice in the second method, I went around one full rotation, which was the 2 pi, then plus a remainder of a 1/4 pi to determine where the location is of that terminal ray. So this measurement is the measure of 9/4 pi. We'll find out later that it also lines up, which we already knew, on 1/4 pi. So it's 1/4 pi plus another full rotation. Kind of a cool coincidence that happened as well. But this one, its angle is 9/4 pi. Now, I have a lot of information in front of you, and I just want to present it now just to give us an idea of some of the chunks we're going to be adding along the way. Notice that I have a circle, and I divided it up and I put angles or measurements at some of the key points that we're going to discover over and over and over again. Again, how many angles are there within a circle? There's an infinite amount of angles. So I only have a limited number of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 angles out of infinity that I think are going to pop up over and over and over again. So I want to give you a couple of clues of what's happening here. First of all, notice that I have the circle broken up into eighths. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and back to 8/8. And each of those has a radian measure and a degree measure that we're going to become comfortable with. Next, I divided the circle up into thirds. I have 1/3, 2/3, 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, and so forth. So I also broke it up into thirds as well. Along these points, notice a couple things. Notice everything that's on the eighth mark, all my eighths. All end with a 4 or is within a 4. So anything that's a radian fraction that's over a 4, that's right at the midway points between the x and the y axis. Maybe just a way to kind of memorize them. Notice that my other two ratios, one is over a 6 and one's over a 3. Over a 3, over a 6. Over 6, over a 3. Over a 3, over a 6. Notice that all the ones that are over the 6's, those are the ones closer to the x-axis, and the ones over the 3, they're closer to the y-axis. Hopefully those will be some of the clues that you'll start to look for as you start to get a sense of where do these angles lie within a circle. Also notice that in pink around the circle that this is 1/12 around the circle. This is 1/8 around the circle. 1/6 around the circle. 1/4, 1/3, 1/2, 2/3, 3/4, and 7/8, and one full revolution around the circle. Again, I guess my point here is saying is it looks like a lot of information, but it really isn't if you think of it in context of all the possible angles that there are. So as we proceed forward from here, these are probably the benchmarks or the angles that we're going to land on most of the time to help us understand how do we use angles as we reflect and begin our experience with trigonometry. We could look at all the angles in the world, but we're going to limit it to these as our primary angles to start with to build our skills.